Hello everyone. Welcome to the session of Theory of Computation and Formal Languages and Automata Theory. In today's session, we will discuss about the minimization of DFA using MYHILL NERODE theorem. Okay. So actually, this is the question which was asked in the previous question paper. So as I told that I will explain that concept in the next session. So I think this is the right time to discuss about this theorem, MYHILL-Nerode theorem. So actually, this is the question from the first unit. So where we have to minimize the given DFA by using this MYHILL-Nerode theorem. Okay. So here the input for this algorithm is the DFA. So we have to give a DFA as input. The output of this algorithm will be the minimized DFA. Okay. So let us have a look on the steps that we use for minimizing the DFA. So first step is that we have to draw a table for R pairs of states P comma Q. So from the given DFA, we have to identify the pair of states. Okay, and based on that pair of states we have to draw a table. Okay, so just remember this point. I will show with one example. So the first point is that we have to draw a table for all pairs of states. Okay, so let me consider in the given DFA you are having two states q0 comma q1. So you have to draw a table that is consisting of two rows and two columns, right? So let me say q0 q1. Okay, so same we are going to have two columns q0 q1. So two rows q0 q1, two columns q0 q1, right? And next one, eliminate the duplicate cells in the table. So next step is that we have to identify the duplicate cells and we have to remove from the table. Okay, next one, step 3 is that consider every pair p comma q in the DFA. Okay, so we have to consider after removing the duplicate cells in the table. From that table we have to select the pair of states like p comma q, and we have to find whether they are equivalent or not, right? So how do we find? One is that if p is a final state and q is not a final state, okay, or vice versa, then mark that state pq with a cross in a table, right? So what we have to do, we have to consider the table which is obtained after step 2, and we have to consider the every pair of states which is there in a table, and we have to check whether if p is belonging to final state and q is also belongs to final state or not, right? So if p belongs to final state and q does not belongs to final state, then we have to mark that particular pair of states with a cross in a table. Okay, so that is the point. Next one, we have to check for equivalence. So again we have to check whether the two states p and q are equivalent or not, so by using these two properties. So already you know these two properties. So if there is a transition from p on input a gives the final state, that means if uh, processing A from P gives a final state, then it implies that processing input A from Q also gives a final state, right? So if this property holds good, then we can say that the two states P and Q are equivalent, right? So another one is that if uh, P on A does not gives a final state, okay, if transition from P on A does not gives a final state, then it implies that the transition from Q on A also doesn't give the final state, right? So when you apply a transition on input symbol A from state P and Q, you must get either final state or you must not get that you must get either final state or non-final state, right? So these are the two properties. So if any of the property holds good, then we can say that the two states p and q are equivalent. Okay, so that is step 3. Okay, next step 4 is that repeat step 3 until we cannot mark any more states, right? So we have to apply the step 3 for marking the pair of states in a table. So as long as we are having these unmarked states, what we will do, we have to repeat the step 3. Okay, and if we cannot able to mark any more states in the table, then the process ends. Okay, so here if you could see fourth point, if there is unmarked pair p comma q, mark it if the pair transition from p comma a, that is delta of p comma a comma delta of q comma a, is already marked, right? So I will explain this how to mark it. So we have to repeat the step 3 until we don't have any further states to mark in the table, right? And next one, step 5 is that combine all unmarked pairs and make them as a single state, right? So whatever the unmarked states are there in a table, you have to combine those states as a single state. Okay, so let us apply these steps. So what you have to do here is that just try to solve the problem here with these steps, okay, parallelly. So this is the question: minimize the given DFA using MYHILL Nerode theorem. So Q naught on 0 is Q1, Q naught on 1 is Q2, Q1 on 0 Q1 itself, Q1 on 1 it is going to Q3, then Q2 on 0 it is going to Q1, Q2 on 1 self transition, okay, Q3 on 0 Q1, Q3 on 1 Q4, Q4 on 0 Q1, Q4 on Q1, Q4 on 1 Q2, okay, and here the Q4 is the final state. Okay, now so this is the given DFA. We have to apply this theorem and we have to minimize it, right? So first step, see here, construct the table, right? So see how we are going to construct the table. As point number 1, for every pair of states we have to construct this particular table. That means there should be an entry. So what are the states we are having? We are having Q0, Q1, Q2, Q3, Q4. So write down those states row wise: Q0, Q1, Q2, Q3, Q4, and write down the same state in the column wise also: Q0, Q1, Q2, Q3, Q4. Okay, so this is nothing but simply writing or creating an entry or cell for every pair of states, right? So one pair you could take Q0 gamma Q0, another pair you could take like Q0 gamma Q1, Q0 gamma Q2, Q0 gamma Q3, Q0 gamma Q4, likewise, right? So by considering that property, we are generating this table, right? So it is simply like if you are having n state, then you are going to have n into n, okay, size table here, right? So Q, these are the states: Q0, Q1, Q2, Q3, Q4, Q0, Q1, Q2, Q3, Q4, right? The next one, after drawing this table, the first thing what you have to do here is that a state cannot be compared to itself. So mark some p comma p with x. So we could not able to compare the same state with itself, right? So we could not able to compare a state with itself, right? So whenever we have a pair like p comma p, that means same states, uh, we have to mark with a cross, okay, cross here, right? So when I am using the word as mark, you have to mark it as with a cross one, okay. Then next one. So here, see Q naught, Q naught. So in Q naught row, Q naught column, I marked a cross, right? Then Q1, Q1. So we cannot compare Q1, Q1. So I marked with a cross. Next Q2, Q2, we cannot compare, marked with a cross. Q3, Q3, we cannot compare, so marked with a cross. Q4, Q4, we cannot compare, so marked with a cross. Okay. So this is the first step that you have to do after constructing the table. Okay. Next, see here, uh, this is the first thing that we have done, okay. So same state that we are having: Q0 comma Q0 mark with x, Q1 comma Q1 mark with x, or into Q2 comma Q2 mark with x, and so on, right? So now next step is that we have to identify the duplicate cells, right? So duplicate cell means you could see here whatever the unmarked states are there, so we have to consider those and we have to identify the duplicate one, right? So see here, we are having Q1 here. You see the column Q1 and the row is Q0. So Q1, Q0 we are having here, okay, this cell, that means this column. And if you consider the Q1 row and Q0 column, again we are having the cell that is indicating Q1 comma Q0, right? So this cell Q1 comma Q0 and this cell Q0 comma Q1, right? So both are same, right? So this we could say like it is a duplicate one, right? So we have to mark one cell and we have to consider the another one, right? So let me consider that I am marking Q0 Q1 cell with a cross, okay, because I am already having Q1 Q0. That means in Q1 row, in Q0 column, I am having the cell or pair that is representing the same state. So I am crossing that Q0 Q1. That means Q0 row, Q1 column cell with a cross, okay. So that I am considering it as a duplicate one. So I am thinking to remove that duplicate cell, okay. So see here, So just I marked Q0 Q1, Q0 row Q1 column with a cross, then Q0 row Q2 column with a cross, Q0 row with a Q3 column with a cross, Q0 row Q4 column with a cross. So diagonally whatever the states are there, that means above the diagonal whatever the states are there, whatever the cells are there, that are going to be removed. Okay, so why? Because those cells will be considered as the duplicate cells, or those pair of states will be considered as the duplicate pairs, right? So from the diagonal, upward diagonals, we have to remove all those cells. Okay, so that is nothing but removing the duplicate cells. Okay, so now after removing the duplicate cells, you get the table, concise table like this. So whatever the cross is there, you have to eliminate all those cells, right? So cells that are having cross, that should be eliminated. Okay, so what happens if you eliminate this one? Q0 cell will be eliminated. Why? Because it is having cross, right? So same is the case with Q0 Q1, Q0 Q2, Q0 Q3, Q0 Q4. So that's the reason we are not going to have Q0 row in the modified table, right? So that's why the modified table starts with Q1. Okay, and in Q1 we are going to have only one cell with a column, that is Q0, right? In Q2 we are going to have two cells, right? So whatever the empty cells that are there in the uh, table, previous table, those cells we are going to be considered in the modified one, right? So here you could see Q0 Q1 Q0 empty cell, Q2 Q0 empty cell, Q2 Q1 empty cell, Q3 Q0, Q3 Q1, Q3 Q2. Okay, and we are having the Q4. Okay, now then we have to consider the every pair of states. Okay, and if one state is the final state, another one is the non-final state, then we have to mark that pair with a cross, right? So see here, I have taken the first combination Q0 Q4, right? So I have taken the first combination Q0 Q4. So Q0 Q4 means Q0 is a non-final state, Q4 is a final state. So what I have to do here is that we have to mark this, that means this Q4 as a by a cross, right? So we have to mark this Q4 with a cross. Okay, so next one, that means Q1 Q4. So Q1 is non-final state and Q4 is the final state, right? So Q2 is non-final state, Q4 is the final state, right? So this we have to mark, that means Q3 comma Q4. Q3 is a final state, Q4 is, sorry, Q3 is non-final state, Q4 is a final state, right? So anyhow, to concise this discussion, I would say like whatever the final state is there in that particular row, mark with a cross, right? So Q4 is a final state, so mark that Q4 related entire row with a cross. Okay, with a cross. So this is the modified table, right? So after eliminating the duplicate cells, and what we have to do, we have to mark the entire row that belongs to the final state with a cross. Okay, so why we are marking, I explained that, right? So we are taking the each combination, that is Q0 Q4. So Q0 Q4, Q0 is a Q0 is a non-final state, Q4 is a final state. So that pair we have to mark with a cross. So that pair where we are getting Q4 row Q0 column. So that's why we are marking with cross. Next to Q1 Q4. So Q1 is non-final state, Q4 is a final state. So we are marking Q4 Q1 with a cross. Okay, next Q4 Q2. So here just don't get confused. The combination Q0 Q4 or Q4 Q0 both are same, right? So the combination both are same, right? So as we have eliminated the duplicate cells, we are not going to have Q0 Q4 combination, right? So it is similar to that Q4 comma Q0, right? So anyway, Q0 Q4 or Q4 Q0 both are same, right? So likewise, we are marking this entire Q4 with a cross. Why? Because it is a final state. Okay. So that's it up to this part. Now, so after marking, now we have to check every pair of cells, that is here you could see the empty cells. So what are the combinations that you get? Q0 Q1 one combination, then Q1 Q2 another combination. Okay, Q0 Q2 another combination. So empty cells that we are having, you have to take those pair as a, that means row or column as a pair, right? So you could take either Q1 Q0 or Q0 Q1, both are same, right? So empty cell pairs, if you could see, it is like Q0 Q1. Okay, first cell. Next you could say like Q0 Q2, Q1 Q2, Q0 Q3, Q1 Q3, Q2 Q3, Q0 Q4, Q1 Q4, Q2 Q4, Q3 Q4. Okay, so likewise. So we have to take each pair like this. Let me select the first from top cell. I am considering the pair of states Q0 comma Q1, right? So check for equivalence. So what we have to do, already we know that how to check the equivalence, right? So consider delta of Q0 comma 0. So it is Q1, and similarly consider delta of Q1 comma 0. Check where it is going on 0. It is going to Q1. So both Q1 Q1. So check Q1 Q1 are marked. No. So Q1 Q1 are not marked, right? So we never have a combination Q1 comma Q1, so it was not marked. So it was not marked in a table. Then we check for equivalence on the next input, other input 1. So delta of Q0 comma 1 Q2, delta of Q1 comma 1 Q3. Okay. So now what is the state that you got? What is the combination that you got? Q0, sorry, Q2 Q3, right? So do we have Q2 Q3 marked in a table? So we are not having that Q2 Q3 marked in a table, right? So we cannot mark Q0 Q1 also. Okay, so we cannot mark Q0 Q1 in a table. Okay, so that is the thing. So that thing we have to check. So just check out the states, pair of states that we are getting on applying the transition on input. If those pair of states are marked, then the considered pair of states will also be marked, right? So here if you see delta of Q0 comma 1 we got Q2, delta of Q1 comma 1 we got Q3. So what is the pair that we got? Q2 Q3. Okay, so Q2 Q3 or Q3 Q2 both are same. So how do you consider with respect to the table? Both are same, right? So is there any marking with Q2 Q3? No, so it is empty. So that's why we are not marking Q0 Q1 also. So we are not marking the cell related to Q0 Q1 or Q1 Q0, right? Next one. So consider the next cell. Let me take Q0 Q2. Okay. So Q0 Q2. So just I am applying the transition delta of Q0 comma 0. It is giving Q1. Delta of Q2 comma 0. It is giving Q1. So we never have a state that means cell marked with Q1 Q1, right? So we don't have. So that's why we are checking for another input delta of Q0 comma 1 is equal to Q2. So delta of Q2 comma 1 is equal to Q2. So we never have a Q2 Q2 combination pair which is marked in a table, right? So that's why we are not marking Q0 Q2 and checking for next unmarked cell. So we are considering unmarked cell, that is Q0 Q3, right? So Q0 Q3, check it. So delta of Q0 comma 0 it is Q1, delta of Q3 comma 0 it is Q1, right? So we don't have a marking with Q1 Q1, so that's why we are checking for another input. So delta of Q0 comma 1 it is giving Q2, delta of Q3 comma 1 it is giving Q4. So here you could see Q2 does not belongs to final state, Q4 belongs to final state, right? So here you could say that Q0 Q3 are not equivalent, right? So we have to mark Q0 Q3 in a table, right? So you could also see the combination Q2 Q4, right? So Q2 Q4 if you see it is already marked, right? So here see this one. So Q4 row Q2 column it is already marked with a cross, right? Since Q2 Q4 pair is already marked, we can also mark Q0 Q3 also in a table, right? So if you see modified table, I marked Q0 Q3 in a table, right? So with a cross. Okay. So you could find Q0 Q3, that means Q3 row Q0 column is marked with a cross. Okay. Next empty cell that we have to take here is Q1 Q2. Okay. So Q1 Q2, check for equivalence. Okay. So Q0 on 0 Q1, Q2 on 0 Q1. So we cannot have a cell marked with that means cell with Q1 Q1 combination. So we are checking for next input delta of Q1 comma 1 is equal to Q3, delta of Q2 comma 1 is equal to Q2. So check whether 3 2 is already marked, 2 3 is already marked, 2 3 is already marked or no. Okay. So since 2 3 is not marked, so we are leaving that Q1 Q2 as it is. Okay. Next one. So next empty cell you have to take what is the next one? From this diagram you have to select, right? Q1 Q3. So Q1 Q2 already over. Next you have to select Q1 Q3 or it is similar to Q3 Q1. So whatever, how do you perceive, it is up to you. So just I am writing in a sequence, right? So smaller number I am writing first, larger number I am writing next, right? So Q1 Q3. So that means it is like something Q3 row Q1 column. So we are checking that state. So Q1 comma Q3. So Q1 on 0 Q1, Q3 on 0 Q1. So both are same. So that's why we are checking for Q1 on 1, that is Q3, Q3 on 1 Q4. So 3 and 4 check Q3 Q4. It is already marked. Okay. So it is already marked, I think. So Q3 Q4 already marked. So that's why we are marking Q1 Q3 also. So that's why in table I marked Q1 Q3 with a cross. Okay. So or you could say like Q3 row Q1 column is marked with a cross. Okay. Next one. So consider next empty cell from this table. So next empty cell is Q2 Q3. Okay. So Q2 Q3. So Q2 Q3 Q2 on 0 Q1 Q3 on 0 Q1 Q2 on 1 Q2 Q3 on 1 Q4. So check Q2 Q4. So already that Q2 Q4 means this combination. So Q4 row Q2 column. So it was already marked. So that's why we are marking this cell also. What is that cell? Q2 Q3. So we are marking this cell Q2 Q3. Okay. So this is the table after applying the first iteration, right? So after applying all the that means after checking all the pair of states, this completes our first iteration, right? So after a completion of the first iteration, Q3 is completely marked, Q4 state is completely marked, right? So now next combination is Q0 Q1, Q0 Q2, Q1 Q2. So these states we have to check and mark. Okay. So here I have written like again start next iteration by considering unmarked pairs, right? So unmarked pair means what are the unmarked pairs? Q0 Q1, Q0 Q2, Q1 Q2. Okay. So consider the first one Q0 Q1. So same Q0 on 0 Q1, Q1 on 0 Q1. So we don't have a cell with Q1 Q1 combination. So that's why we are checking for input 1, Q0 on 1 2, Q1 on 1 Q3. So check 2 3 is already marked. So in this table 2 3 is marked. Yes. So that means Q3 and Q2 column. It is already marked. Since it is already marked, we are marking Q0 Q1 in a table. Okay. So see, this is a modified table where we marked Q0 and Q1 cell. Okay. Next, so from this table, select the next pair Q0 Q2. So that is Q0 Q2. So this is Q0 Q2. So Q0 on 0 Q1, Q2 on 0 Q1, Q0 on 1 Q2, Q2 on 1 Q2. So we don't have cells with Q1 Q1 Q2 Q2. So leave it. We cannot mark it. So next combination, select from this table Q1 Q2. So left one is Q1 Q2. So check Q1 Q2. So Q1 on 0 Q1, Q2 on 0 Q1, Q1 on 1 Q3, Q2 on 1 Q2. So check whether 2 3 is already marked. Yes, 2 3 is already marked. So mark Q1 Q2 in the table. Okay. So mark Q1 Q2 in the table. So this is the modified table after marking Q1 Q2. So Q1 Q2. So this second iteration was over. Now again start the third iteration since we are having one more unmarked cell, right? So again consider the empty cell which we are having Q0 Q2, or you could also write Q2 comma Q0. So your wish, how do you consider? It's up to you. So check the transition Q0 on 0 Q1, Q2 on 0 Q1. Okay. So it is Q1 only. So check for input 1, Q0 on 1 Q2, Q2 on 1 Q2. So both the states are same. So we cannot mark Q0 Q2, right? So now if you check here, uh, the table that is obtained after this step and the previous table both are same, right? So whenever the table remains unchanged, we have to stop this procedure, right? So we have to keep on iterating for every unmarked pair of cells, okay, unmarked states. uh, as long as the table is changing, we have to repeat it. So whenever there is no change in the table, we stop this procedure. So here if you repeat again Q0 comma Q2, if you check it again, the table will remain same. Okay, it will not change. So here we stop this algorithm. So no change in table entries. So stop the procedure and apply step 5. Okay. So what is step 5? So unmarked cells are there. They have to combine as a single state. So what is unmarked cell? We are having Q0 Q2. Okay. Or you could consider it as Q2 Q0. So we are having unmarked cell, that is Q0 and Q2, Q0 Q2. So we have to merge these two states as a single one, right? So merge these two states as a single one. So you will get the state Q0 Q2 as a single one and remaining states as it is. Okay. So construct the minimized DFA by merging the unmarked states as a single state, right? So Q naught Q2 will become a single state. So what is the starting state? So Q naught is the starting state in a given diagram. So in merging, we are having Q naught here. So that Q naught Q2 will become the start state, right? Why? Because in the given DFA, Q naught is the starting state, right? So we have merged Q naught Q2 as a single state. So this Q naught Q2 state will become a start state, right? And then specify the transition by seeing the DFA which is given in the problem, right? So what is there? Q naught on 0, it is going to Q1. Q naught on 1, it is going to Q2. So Q2 is also the same state. So that's why we are having the self transition. Okay. So Q1 on 0, it is Q1 itself. Q1 on 1, it is Q3. Okay. So Q2 on 0, it is going to Q1. So Q2 is already merged with Q naught. So we need not again specify the transition. Q naught on 1, it is Q2 itself. Sorry, Q2 on 1, it is Q2 itself. So already Q naught Q2 is merged. So if you consider that transition in the problem, you will get the self transition in this minimized DFA, right? Then next one, Q3 on 0 Q1, Q3 on 1 Q4, Q4 on 0 Q1, Q4 on 1 Q2. So here Q2 is already merged. So that's why we are having transition from Q4 on 1 towards Q naught Q2. Okay. As Q4 is the final state, it will remain as it is. Okay. So in the given DFA, there are 6 states, I think so, 5 states. Okay. 5 states. But here in the minimized DFA, we got only 4 states, right? So this is how we use this MYHILL Nerode theorem for minimizing the DFA. Okay. So it is very easy. Just you have to apply these 5 steps, right? So just go through the algorithm once. Okay. So and moreover, what we have to do here is that we have to mark the cells. Okay. So if the cells are not equivalent, what we are doing, we are marking them. Okay. So equivalent cell will never be marked, right? So see here in the resultant table, Q naught Q2 remain unmarked. Okay. Why? Because Q naught Q2 are equivalent, right? So inequivalent states will be marked with a cross. Okay. So just what we are doing here is that we are using this theorem and we are identifying which states are equivalent and which states are not equivalent. Okay. By marking them, by marking and unmarking them. Okay. So this is the MYHILL Nerode theorem. So just go through it once. If you feel any difficulty in solving the problems by applying this theorem, just bring it to my notice. I will try to clarify all your doubts in the next session. Okay. So that's it for today's session. Thank you for attending the session.